Good afternoon. Thank you for joining us today. My name's Alec McCutcheon. I'm a Director of Unicom Seminars. We're very pleased to be hosting a webinar this afternoon entitled Continuous Delivery, What It Is and How to Achieve It. The webinar is presented by Panay Iasemidis, who's a Senior Consultant focusing on DevOps at CA. Panay has many years experience, practical experience, so really will bring this webinar to life, and I'm going to, without further ado, hand over to Panay.
Hi everybody, thank you Alec. Thank you for joining us on our continuous delivery webinar today. We're going to look at how we do things, how we deliver applications today, see if there's a better way of doing it, what is it that we need to do to improve things, how do we measure our progress, and we will also take a look at how CA does things as well. So that's a very, very quick review of the agenda. You might often hear people talking of maturity models, and believe it or not, application delivery and continuous delivery also have a maturity model. And before we look at that, if we cast our minds back on how we were doing IT 40 years ago, just to illustrate things, okay, a programmer would write his program, maybe put it on punch cards or paper tape. He'd have a job control deck, a data deck, he'd give it to the operators, and he'd walk away, leave them to do it, and he'd come back in a few hours or maybe the next day. If you think about it, the program deck was the application, the data deck was the database, and the JCL was the script. So 4 days ago, I was talking to a customer, and he sent an email with an XLS spreadsheet attached and a file server URL to the operations team, and he expected them to get on with it. So really, it hasn't changed much in 40 years. The irony is, of course, that consumer-facing IT has changed dramatically. We don't tend to queue up nowadays very often in, say, HMV or Virgin or wherever it is to buy our CDs or our DVDs. We tend to go online and do a lot of our shopping. So consumer-facing IT has changed dramatically, yet the way IT operates internally, although it's more complex than it was, has remained essentially the same. So perhaps there is some room for improvement. So this is the early stages of the maturity model. Manual deployments speaks for itself. So people copy files manually, they edit the database configurations, port numbers, they log in with credentials, they take output information, they take it to another server, enter that connection information into another system, and so forth. So the most obvious step for people to automate, to go to level 2 as we call it, is to script. So people sit down and write scripts in various languages. A lot use things like, say, Perl or Unix shell scripts or Windows command files, and there's also various other tools that do scripting as well. The thing about scripting is, though, it can be platform dependent. So I may write a script that works on, say, Windows, but if I want to go to a Linux system, the same script won't work necessarily. Also, a script is written by subject matter experts. So I might have my web server administrators, my application server administrators like WebLogic or WebSphere. I might have my database administrators. And each of these subject matter experts will end up doing their own scripts. So scripts are a bit of a black box. Not necessarily everybody knows what's going on in everybody else's script. And some of the problems we sometimes see with the way applications are delivered in a lot of organizations today is that they might either miss go live dates or they have a problem in the release. It's difficult to find out, is the problem in the release actually in the application itself, or is it in the way the application was deployed? And they struggle a little bit to find out how to fix things. So what we're looking to do initially is to automate the process that exists currently and so to make it reusable. And that way we're harnessing the intellectual property that we already have, perhaps in scripts, in existing processes, and we actually use that to take the next step to level 3 and automate more or less what we have. Now, of course, you don't want to go automating a bad process, but if your process works reasonably well, it's worth pulling it all together, orchestrating it well, and automating it. Once you've automated it, you can then say, well, can I now make it run continuously? So you can initially automate taking artifacts from deployment, putting them into test. When that all works well, you then execute the same procedure and you deploy into one of your staging environments. And then if that all works well and passes the approval gates, you then redeploy that again using the same procedure into production. So the same procedure is used to deploy in all environments. So the deployment procedure is as thoroughly tested as the application itself. Now, if that's all working very, very well, you can then automate the whole pipeline. So you then start to achieve continuous delivery, because you can run your automated tests. If there's a bug, you send a bug report back to development saying this was the test in the application that failed, this was the input data, the output data that we expected, this was the output that we got, and so the development have all the information they need to fix the problem. If all the tests pass in, say, a test stage, you can then move it on to the next stage. If there's approval gates needed, you can invoke those. So if a release actually passes all of the tests at each stage, you could promote it all the way to UAT or even production if you wish. So this now becomes continuous. And then optimization is the one that we'll look at in a little bit more detail in a moment. But the idea is that once you've got your deployment procedures automated and continuous, you can now start, rather than releasing large changes to an application once every few months, to actually start delivering smaller changes to the application at more frequent intervals, becoming more responsive to business needs. So if we look at how we make our way up the maturity model, where do we start? We usually find that in most human endeavors, and IT is no exception, there are three main constraints: quality or risk management, time and cost. It's difficult to have a positive effect on one of these without having a negative effect on one of the others. So if I want to improve quality, I either need to spend more time or more money. If I decide to do things quicker, then quality will fall or my costs will go up, and so forth. If I want to save money, it's either going to take longer to do things or quality will suffer. So the only way to improve things is to find a better way of doing things and affect one of these and then use that as a lever to affect the others. So what we tend to do with application release automation and continuous delivery is we go for the quality. We improve the quality, we automate it, we make it reusable. That means we can deliver things more quickly. We keep our costs constant probably, but we find that we can actually make releases better quality, more reliable, more consistent, and therefore take the next step. So we have automation and reuse initially, gives us shorter release cycles. If we have shorter release cycles, each release can have less code changes in it. So not only are we more responsive to the business, but because we're deploying smaller packages, there's a reduced risk. So we start having a positive spiral effect here. The development starts feeding into itself. It's all automated. We can do more tasks in less time. Now, you will find, of course, that there's a lot of variation across organizations, and what's right for one organization is not necessarily the best for another. It's something that's well worthy of discussion in your organization. The other thing, of course, that you need is visibility. You need to be able to monitor and prove that the quality is improving, that costs have gone down, or that time has improved, and so forth. Sometimes you hear these three variables referred to as time, control, and visibility. If we look at how Wikipedia defines continuous delivery, it's a design practice to automate and improve the process of software delivery. You will have heard probably of techniques such as agile, continuous integration, continuous build, continuous deployment, and automated testing. The idea, again, as Wikipedia says, is you reduce time, reduce manual effort, increase consistency and quality. And I've got the URL there at the bottom, and if you just search for continuous delivery on Wikipedia, they've got an excellent article on it and a very nice diagram that shows the different stages of application development through test, different stages and into production. Now, the reason some of these challenges exist today is because most organizations still have a typical development IT operations organization. Some also have a third, which is infrastructure, but many have infrastructure and IT ops in the one department. So development organizations have recently done a lot of work, and there's a lot of books and information out there on how to improve your development processes. So you will have heard terms like agile. We've heard of test automation tools, continuous integration, and build servers. And this is all stuff that enables developers and development teams to be much more responsive to business needs. So you have a business idea and produce the code for it in a relatively short amount of time. You write your code, you do some elementary tests. If it's fine, you check it back into the repository, and a continuous integration server will take it, compile it, check it into the artifact repository, or even build a complete application and again check it into the artifact repository. We then have IT operations take over to do the release, and they are responsible usually for setting up the environments that the release will go into, whether that be test or some other staging environment, and ultimately production. Some of the challenges IT ops face is, of course, that they need to track all of these releases. So they may have different releases in test, different releases in UAT, and other releases in production. And of course, they usually have to support the production systems. What sometimes happens is that, say, there's a bug found in the production system and it goes back to development to fix it. IT operations find they have to go back and reconstruct old versions of the test environment or the UAT environment so that they can rerun the tests after development to fix any problems they've encountered. So we're looking for a way to enable the subject matter experts in development and IT operations to share information and work more effectively together. This is what the whole concept of DevOps is about. And when you actually solve this problem, that's when you are able to achieve what we call continuous delivery. Now, continuous delivery isn't anything new. It's mission critical to a lot of organizations, many of whom I'm sure you've heard of. These are some of the organizations that have invented it, and they've learned how to do it. And someone once said, pointed out that not all large businesses work the same way. The biggest challenge can be the technology museum, and we'll see this in one of the examples that we discuss a little later. The challenge is to make an informed decision on how far an established business can go towards improving delivery without undertaking unnecessary risks and costs. Now, many of these companies here maintain public blog posts about how they've achieved continuous delivery, so you might want to look on their websites, so do some searches and read some of the blogs that are out there. But essentially, what all of these businesses that we see in front of us have in common is that their customers are web-facing or mobile app-facing. So any business that's faced with maintaining a customer presence in the marketplace on the web or on mobile devices will need some kind of responsive mechanism to deliver market needs to their customers more quickly. So two of the essential concepts of continuous delivery. The first one is, of course, as we mentioned earlier, is the continuous integration. And I think that the screens are taking a few moments to update. Okay. So developers checking their code, the build server picks it up, compiles it, builds it, checks it into the artifact repository. There's different kinds of files, whether they're EAR files, WAR files, and so forth. And then while it's in the repository, that's where release automation can take over from continuous integration and start the continuous delivery process. Now, the way we do this today is where some of the challenges occur. Some people may ask, well, okay, you have a package, how hard can it be to deploy it? And the problem is, it's back to the number of subject matter experts that are required to deploy an application across multiple elements in a stack, whether it's web, application server, database, back-end legacy systems, and so forth. So no one person has the knowledge, information, or capability to do it all. We have to develop a process to do it, but it can be lengthy and slow if it's manual. Some of the problems we often encounter that we seek to resolve are use of scripts. So you've got some existing scripts. Are they still suitable and up to date? Who wrote them? Are we using the same scripts across all of our environments, from test through UAT to production? Are we using the same type of scripts on the same types of servers across the different environments? Are there user ID, passwords, and other credentials embedded in the scripts? If not, do we need to set environment variables in advance, or do we enter the credentials by hand each time we do a deployment? We also need to be able to deal with differences between different operating systems, databases, and the various prereqs that a particular environment will have for the particular application that you want to deploy. So which servers do I run the scripts on? Also, how do I configure network, firewalls, load balancers, and other systems? Also, in what sequence do I need to run the scripts? So how do I pass parameters and outputs from one script running on one system to another script on another system? Also, some of these parameters are the same across all the systems or across all of the environments. And in other cases, some of these parameters and outputs vary across systems in the stack or across environments. So again, we need a way of dealing with the data flow between the different scripts and processes of the deployment task. So how I deploy a package from development into test may seem like a simple task, but it can be quite complex with a lot of manual intervention, even when scripts are used. And some of the indicators for this are relatively straightforward. If you have people who are having to work weekends or late into the night to get a release done, or if they have to carry pages on mobile phones and be on call in case there's a problem, that's usually an indicator that you really would benefit from an application release automation solution and ultimately continuous delivery. Other indicators are things like runbooks, Word docs and spreadsheets, or tribal knowledge as it's sometimes called, where you have a tightly knit team that know how the application works, but a tightly knit team can only scale up to a certain point. There's limits to how much a group of people can achieve. So finding a way to enable them to do more, enabling them to do less mundane work will add value to the business. So to bring it all together, we need a tool that allows subject matter experts to share, consolidate, and automate their knowledge. It needs to be able to interface to continuous integration, continuous build systems, artifact repositories. It needs to be able to deliver the requirements also that certain regulatory and statutory requirements have. So, for example, certain types of business, like in the finance or personally identifiable information, for example, in health, require vulnerability scans to be done on the code before it's compiled and deployed. So being able to hook into these systems, being able to audit everything and ensure that you can give the appropriate reports to the auditors and the accreditors is something that you also need your tool to be able to do for you. You also need to be able to determine when you're deploying an application whether some of the backends are real backends or whether you're going to virtualize and simulate some of them for testing purposes to make your testing more efficient. You also want to be able to do your defect tracking, bug reports, send information back to development to enable them to resolve problems quickly. Other integration points are on-demand environments, so you may have, say, physical servers in dev, you may have virtual machines from various providers in the different test stages, and you may be in the cloud for production. So again, you need to be able to integrate to these different systems. Or change requests systems, change management systems. Is although we have a suite of tools including testing, simulation, automation, and hybrid environment management. So looking at release automation first, delivery solutions. So you have a central database, there's a design tool, and so forth, can actually specify the deployment steps for each application, put them into the, you're not picking up somebody else's script and attempting to figure out what it's doing. It's visually clear to you. They can then more easily coordinate each other's efforts because they can see the steps that each one requires to do the deployment. They can actually integrate better, share parameters, share variables, coordinate deployment activities across systems. You also often hear the word DevOps used to talk about continuous delivery or release automation. DevOps is more of a philosophy of how to go about bringing developers and operations closer together and enabling them to work better. And things like continuous integration, continuous delivery, release automation are, if you like, ways of achieving the DevOps philosophy. So what we aim to do with the release automation at CA is actually meet these criteria here, to be able to improve quality, reduce time, and keep costs down. and then give you automation and reuse and make everything more responsive to the business, have less mundane work for people to do manually, and essentially reduce risk and enable frequent release so that you're more responsive. Gartner's view on some of this stuff is interesting as well. So according to Gartner, more than 95% of companies lack a centralized release management process. So they've got different teams doing different parts. Where the split occurs sometimes, depending on the infrastructure, is there are development teams, operations teams, and infrastructure teams. And although developers tend to work on a particular application, and the infrastructure teams tend to work on all of the infrastructure, operations teams are sometimes split into two ways. Some operations teams are focused on particular applications, and other operations teams are focused on different parts of the infrastructure. So the crossover point between DevOps can in fact go all the way down to the infrastructure teams as well. So this is again something that needs coordination. So a lot of organizations are still doing things manually. There can be consistency problems. And what else do they say? Okay, so essentially what they're saying is release automation is the first step, which is true. It's the first step into actually improving how you do your deployments. So you need to start somewhere. You need to look at how many deployments you're doing, how many applications you have, how many staff you have doing the deployments, look at what you're trying to achieve, and maybe focus on a particular team or a particular application to take the first step. Don't try and do a big bang approach. Take a well-known application or a team that works well together and see if you can help them automate what they have, and then take the later steps after that. In terms of the software and how the software enables you to do this, what CA release automation provides is a release data model, as it were. So you first model the application and how it's delivered independently of any physical hardware architecture. So the idea here is you define the deployment process for the web components, the application components, the database, and any other backend systems, the network, etc., without specifying IP addresses or host names or anything like that. You don't even specify how many servers there will be in each tier in the application. So you define almost an agnostic, decoupled process for doing the development. You also then separately define the environments that you have. So in development, you might have single server, and you run the web, the application, the database, and everything else on one or two servers, and they're physical. In, say, some of the staging environments, you might have 10 web servers, 2 application servers, 2 database servers, and in production, you might have the same, but it's doubled up because you've got high availability as well. So the same procedure that you've defined for deploying the web server on a single server in development should also work when you're deploying the web server on multiple web servers in the UAT or the production environment. And the way you actually get the application model to apply to multiple environments is that you keep a manifest of the environment configuration. So it says, right, these are my web servers, and it lists them. These are my application servers, and it lists them. These are my database servers, and it lists them. You then have a release manifest that says, okay, I want to release a particular application at a particular release number into a particular environment. I have a list of which artifacts, or binary components if you like, go up to make that release. So let's take an example. So I've got 3 environments here. I've got QA, staging, and production. I've got deployment options for my application. I can deploy the application in full, or I might have a process that just deploys an update or a patch of some sort. And I might have multiple versions currently. So although, say, production may be running version 4, I might want to be able to release version 5 to, say, QA. So I actually select 3 variables. I want to say what environment I want to deploy to, what version of the application, and whether it's a full or a partial deployment. And those 3 elements are pulled together to form the release manifest. and that's ready to deploy into QA. If that passes all of the various automated tests that we can manage, it can then be promoted to staging, and again you will pull the staging environment into the manifest so that your deployment will now be customized for staging, and similarly if that passes approval gates you can then automate deployment into production, so you automate the whole thing. So when you're looking at continuous delivery and application release automation tools, these are some of the things that it's worth looking at. So make sure if you can that it's manifest driven, so see if you can decouple the deployment of the application from the physical environments from any specific release as well. A tool should be able to handle multiple apps and multiple environments, and it should enable reuse. It should enable also the different subject matter experts to work together without necessarily having to have each other's knowledge in their heads. This is where an actions library come in. So for example, the way I would deploy SQL to the Sybase is different from a DB2 database, is different from a Microsoft SQL database, is different from, say, an Oracle database. So although they're all running SQL, the connection IDs, the system IDs, the credentials all differ. And there are usually in the DDL quite substantial differences. So if you have predefined action packs that reflect these differences from the databases, then someone who's not a database specialist can actually look at the actions that are defined in the deployment process and make sense of them. You also need to look for the actions to have bidirectional interfaces. So if you've got continuous build systems, for example, it would be good if once they've done a build, they can call the release automation tool. Or if the release automation tool can go and ask the continuous integration system, do you have something for me to deploy? So you want bidirectional integration. You need to be sure that your tools are also scalable in terms of breadth as well as depth. So you want to start small, maybe with tens of servers, and then as you affect more and more applications and you automate the delivery of more and more applications, the number of servers obviously that you're going to be managing will increase. So eventually you need to be able to scale to thousands of servers. And in terms of depth, the solution has to be able to cater for the whole stack. So you've got to be able to manage network appliances, web servers, applications, databases, back-end legacy systems, and so forth. And also automation and workflow. So if you've got existing script systems, you've got existing tools that you're already using but they're not doing the whole job, you have to be able to integrate with them and reuse them. You can't just go big bang and throw things away. That's not going to do anybody any favors. So your automation and your work system essentially have to be able to adopt what you have and orchestrate it and become a single source of the deployment process, a single source of truth, if you like, so that you can have one place where your release managers, your business managers, but also your operations, your DBAs, etc., can go and look and see and know exactly where things are at each stage of the release. You also need it to be platform independent, so you might, as some of my customers were doing, believe it or not, they were developing on Linux and they were deploying to Windows. So I know it sounds strange, but you need to be able to cater for things like that. So reuse, not just in terms of the scripts and the technology that they're deploying, but also the technology that they're deploying onto. If we look at some case studies, so some people find this difficult to believe. You know, I've been doing a deployment manually, or it's been semi-scripted, and it takes 2.5 days, and now it's down to 20 minutes. But if you consider that you may have, say, 30 servers, and you've got a team of, say, 4 people deploying an application, you can easily imagine that it might take them 2.5 days, particularly if there's updates to the database or the OS as well as the application to deploy. If they're doing this manually, you can easily imagine it taking 2.5 days or a weekend. If you then consider that a lot of this work could be automated and run in parallel, and it's not being typed slowly in command by command, line by line, then you can see how things might take as little as 20 minutes. So that's really nearly 2 orders of magnitude. To take some more specific examples, we were working with a Western European bank recently. Their business driver was to reduce time to market for their critical applications. So they wanted to reduce or eliminate manual errors, eliminate the need for rollbacks, or at least if they had to do a rollback, be able to do it more efficiently, and they wanted to eliminate the dependency on people having to work weekends to get an application ready for Monday morning. And after all, a lot of businesses are now 7 days a week, so taking systems out for the weekend is really a no-no for a lot of businesses now. They were using WebSphere application server. They had quite a lot of configuration work to do. They had about 150 production applications and another 1,500 across the development test pipeline. And they managed to reduce a particular task from 4 hours to 5 minutes. If you look at the total amount of improvement in workload they were able to achieve, they were able to improve their workload throughput equivalent to hiring between 15 and 30 new people. So essentially they were able to do more with less, but they used that less to achieve better quality and better consistency. Another bank that we were working with, they had to become more responsive to market changes and market demand, so they're selling more of their products and services online. They wanted to reduce manual errors, improve communications amongst the different subject matter experts and the different teams, and especially on back-end systems integration. I don't know if you're all familiar with the Gartner model that says there's essentially 3 types of IT system. You've got your systems of record, as it were, which lay the foundation for the IT in a business. And these tend to be on mainframes, for example. So these are the things that hold your name, your address, your creditworthiness, and stuff like that. And they're the things that things like auditors look at and make sure they're up to date and secured. You've then got the middle tier systems, which tend to be differentiation systems. So these are the IT systems that add the business value that you have as a business as distinct from your competitors. And then the third tier that Gartner defined is systems of innovation. So these tend to be the systems where they're using web apps or mobile apps to get our customers to do business with us. And a lot of the work, a lot of the churn is up here at this level, at the innovation level, where we're attempting to innovate and turn things around quickly and update our web apps and our special offers and our mobile apps sometimes a number of times each day, but the methods we're using are more geared to the monthly or quarterly releases that we tend to do on main. More frequent deployments, so they were limited to 500 deployments a month across a set of applications, and these were quite chunky changes to the application. And once they automated it, they were able to achieve around 5,000 smaller deployments per month. And they've now actually grown the DevOps project, as it's called, into a continuous delivery project across the worldwide organization. A third one I'd like to look at is a worldwide media organization, and essentially what they wanted to achieve is they don't have applications, they regard it as business services. They want to have release automation as a service. They had development, alpha and beta test environments, as well as 4 sets of production systems. Their systems have to be available 24/7 because when you watch the news, you're probably using the information that these guys are producing minute by minute. They have roughly 100,000 users worldwide. They took an initial set of roughly 20 applications across 2,000 servers, and existing tools in place, you need to be able to reuse them. DevOps is about enabling people to work better together and to enable non-subject matter experts to cooperate more productively. So you also want to include your release managers, your operations people, your developers, and let them be able to know what each other is doing. You need to be able to allow different subject matter experts to work together, understand where each other is in the deployment definition process. You also need to provide a view of the whole application deployment process, which everyone can understand, from business management all the way down to the subject matter experts, so that a business manager can see, yep, this particular release is in development, this particular release is in UAT, this is in production. And they can then decide and make their business plans accordingly, but you also still want to be able to drill down all the way into the bits and bytes so that a subject matter expert like a DBA can also do their job in the overall process. So they're the sort of things you need to look for in a release automation tool. But when we do our release, it has to go on a particular environment. And there is a plethora of environments nowadays, and one of the highest costs an organization faces is maintenance of infrastructure. So that's why there's such a big move to some of the cloud service providers and virtual systems, and some companies are opting to use partial private clouds, partial public clouds. So you need to provide an agile way of maintaining and bringing up and bringing down these environments, because there's no point in maintaining an environment somewhere in the test stages if you're not using it right now. Not right now. You need to take it down and bring it up again when you need it. So you need some kind of tool that will manage your environment, preferably one that's policy-based. So ours uses something that we call blueprints. So you specify your database requirements, your WebSphere or .NET or Java requirements, and so forth. And you take a number of blueprints to define what a particular environment should look like. And it also specifies who and what can be done. So for example, some of the policies you can have at a business level in provision of the application to private cloud, virtual machines, or physical hosts, but not public cloud. If you're a bank, you may have a more rigorous requirement. So if you've got credit cards and PCI data, you might say, actually, I want to limit this data and this part of the application only to be on physical hosts. And then you need to be able to manage the other servers and parts of the environment that sit around that independently. You also need to be able to scale automatically as well, so that if you find that the workload is going to have peaks and troughs at different times of the year, or a particular marketing campaign has been more successful than you'd anticipated, the ability to spin up more systems in a particular environment to handle a bigger load is obviously necessary. This one we've already spoken about, so this is just how we manage all the different elements in an environment. And last but not least, it's worth looking at how these tools need to work together. Again, the communication needs to be completely bidirectional. If you're about to make a release, you need to be able to say, right, this release is targeted at this environment. Is it up? Yes or no? If it's not up, spin it up. Here's the parameters that I need you to configure. If it's up already, then you can go ahead and do the deployment. Similarly, you need to be able to capture information about an environment and pass it back with which to provision other environments moving forward. So you may have configured a particular environment in, say, dev. You want to replicate some aspects of that in the test environment, UAT, and ultimately production. You also need to be able to distinguish whether, for example, in production, you're working with real back-end third-party systems. So say you're a travel agency and you're interfacing into, say, a car hire company's systems. In the development or the test environments, you may not have that, so you may need to simulate it or virtualize it in some way. So again, your release, deployment, and your environment management systems need to be able to decide what components they deploy into dev and test, which are distinct from the ones that they would interface to in production. Right, I think I've overrun a little bit, for which I do apologize, but I don't think I've done too badly, because believe it or not, the presentation originally used to be an hour and a half, so I've tried to condense it as much as possible without losing any information. And I think we'll open it up to question and answer now. Over to you, Alec.
Thanks for that, Panay. So as Panay mentioned, if you've got questions, if you'd like to type them, and we'll read them out, and Panay will endeavour to answer them. I'll just give it a moment for questions to come up. Well, we've got the first question here. This is from Peter de Beja. Panay, do you see continuous deployment as being part of continuous delivery as you use it in this webinar, or do you see it as something different?
Whoops, sorry about that. I was on mute. Continuous deploy. Okay, continuous delivery. I'm trying to think where I saw this. There's a nice diagram that explains the different terminology and how it relates to each other. But going from left to right, some of the terms it defines are continuous integration, which is what development do. And then you've got application delivery, which is what the operations teams do. And then the ability for operations to do application delivery recursively and repeatedly and automated is what continuous deployment is. And then the whole thing from continuous integration and continuous deployment added together give you continuous delivery. I hope I've said that right. Does that make sense?
Thanks, Panay. I don't think we've got any more questions at the moment. Oh, sorry. Beg your pardon, there's one more. This is from Poonam Saharu. Where do you fit release management in the organisation where application delivery is outsourced?
That's an interesting one. Well, that depends on your business process and what your agreement is with the outsourcer who's running the application delivery for you, and who it is that has the final say on whether a release can go out. So you certainly need the tool to be able to say, okay, this is the business process for the approval gates. So your outsourcer will do the development and take the application up to a certain stage, and they might hand it over to you after they've done test, integration, performance testing, and they hand it over to you into your UAT environment. So you might have joint approval gates, or they might just hand over to an environment. That then raises the question, well, do you use the same system and the same network to do the delivery? And the answer is you don't have to. If they're on your network, then that's all well and good, because you can see what they're doing through the different stages if that's part of your agreement. But there's no reason why they couldn't build and automate and have continuous delivery up to a certain point in their environment, and then using the same method that they transmit the deliverable artifacts for the application to you for you to take over and do the release, they can also send to you the continuous delivery procedure if it's been modified in some way. Remember, the idea is that you have reuse here, so when they send you the artifacts to deploy, you should be able to use the same procedure that they did. But if the deployment procedure has changed, they should be able to send you that, and you use that to execute the remaining stages of the delivery in your own environment. And again, the tools we provide allow you to integrate to request management, change management, approval systems, and CMDBs as well. So we deal with that. Anything else?
Another question here. This is from Mike Westwood. What are your top tips to ensure you follow and the most common pitfalls?
Common pitfalls, actually, yeah. Now, oh gosh, it's a difficult one to answer, but it's you often find that a lot of knowledge, although it's documented, there are nuances that aren't documented. So a particular DBA or web server administrator has got documented notes on how to do a release, but there might be an extra line that they need to type in here, or they might need to put spaces or hyphens or backslashes somewhere. It's almost like having a map or a driver's instruction book. There's no replacement for experience, and you often find when you're attempting to automate things, it's very easy to assume that you can take an automation tool and just automate things and put the stuff in there, and to a large extent that's true, but you still need the subject matter experts who know the application, who know the process, to put that information into the tool. So you can't forsake knowledge and just replace it with automation. The tools themselves are pretty straightforward to use. They're really, really simple. So you just need to remember the value of the people in your team. You still need them. What you're essentially doing by deploying tools to automate, reuse, and achieve continuous delivery is you're taking away the mundane work that they would have had to do, maybe the weekends that they'd have to spend doing the work, and you're allowing them to deliver more value to the business. So just beware, you need all your knowledgeable people still there, and make good use of them.
Thanks, Pane. Another question here. This is from Jan Bauman. What metrics would you recommend to track efficiency on your continuous delivery process?
Okay. Well, if you've actually got as far as continuous delivery, you've probably automated measurement of the time it takes to actually do a delivery to each stage, how long it takes to do the tests. Your tests will not only have functionality testing, but they'll also have performance testing in them. So you're gathering metrics with the tool across the entire pipeline and the different tests that you're doing. So you'll be able to make informed decisions on how a continuous delivery project is progressing by looking, is the code still as big as it was? Does it take me as long to deploy as it used to? Are my test rates, is the rate at which I pass the tests that I'm doing, is it increasing or decreasing? So a good tool will provide you all of these metrics so that you'll be able to see the improvement that you're making. And of course, before you make a buying decision, you're going to need some of this information already. You're going to need to look at, say, 1 or 2 apps or a group of developers that you want to help along and say, right, this is how long it takes us to develop something. This is what happens when we test it. This is how long it takes us to get it into production. This is how long it takes us to bring up the infrastructure servers, etc. And as you gradually automate each stage, you're measuring how long it takes you. And you can also even measure, if you wish, how much time people are spending actually specifying the design of the deployment and how many people are still working overtime. If you want to measure people's time as well, you could. But you can usually see the benefit in reduced number of bug reports, for example. You cannot see the improvement in terms of applications being delivered more quickly after the business requirement is first issued. They're usually the sort of parameters that you tend to go for. Just to go back one for a moment, to clarify what I said earlier. So essentially, you've got continuous integration plus continuous deployment equals continuous delivery. Sorry, Alec, back to you.
Okay, quite an interesting question here. This is from Mike Westwood. Mike's asking, what if you have a consultancy company writing the scripts, which will then not be around in 6 months or 12 months' time? Quite an interesting question.
Okay. Let me give that a bit of thought for a sec. Okay. I'm not sure if the question you're asking is to do whether they've written scripts that you're including in your use of the continuous delivery system, or if you're talking about whether they've already put their knowledge of how to do it inside the tool itself. So I'll answer both. But essentially, in the second instance, if the knowledge is in the tool already, then it will be, if you like, clearly visible to people who don't have the same technical expertise. So let's say your Oracle guy has left, and the guy who used to do Microsoft SQL has now taken over. If you're using the tool and the deployment steps, the actions that they take to do a deployment in Oracle are already in the tool, it's very simple and straightforward for a SQL person or even a non-database person to go and look at how it's done in Oracle, because the graphical user interface is self-explanatory about the different parameters that Oracle requires to do a particular action. If the scripts already exist and the person has left, then if the scripts are fit for purpose, you can carry on using them, and a release automation tool will continue to make use of them. But you do want to adopt them as soon as possible. So one of the first steps you do, for example, is you don't go big bang. So you look at what parameters, for example, are embedded in a script that make it specific for a particular server or a particular environment. So you take things like embedded credentials, port numbers, host names, and you actually parameterize them. There are tools that let you do that, for example, with credentials, so that if you've got embedded user IDs, passwords, stuff like that can be supplanted with credential management systems. So you parameterize the script so that it becomes more generic, and then gradually you can start adopting individual procedures or steps from within the script and embed it in the tool if you wish. I hope that answers Mike's question.
Thanks, Pele. So I think that concludes the questions, actually. I can't see any more coming up. So I guess the final part is firstly to thank Pele for an excellent webinar, and also to remind everybody we are now going to do a draw for winning an iPad. We've had quite a...
the iPad, okay.
Would you like us to do the draw, Pele?
Let me just check with my gentleman from marketing who's doing the freebies here.
Okay.
Yeah, Justin says, yeah, you go ahead.
Okay, so I'm just about to draw it. I've got my eyes closed here this end. And the winner is